Good day, everyone. My name is Ahmed Al-Kamal. I will present my work titled Rice Husk Ash Based Sustainable Foam Geopolymer Concrete with Eco-Friendly Foaming Agents for Improved Mechanical and Thermal Insulation. The construction industry is shifting towards sustainable materials. However, ordinary Portland cement contributes about 8% of global CO2 emissions. Geopolymer concrete offer an eco-friendly alternative. Geopolymer concrete is produced by activating aluminosilicate materials using alkaline solutions. This approach aligns with circular economy principles and reduces environment impact. So to address the research gaps and the study objective of this research, the research gaps we have challenges include variability in RHA, rice husk ash, characteristics, limited understanding of foaming agents, and lack of standardized procedures and design. So, in this study, we try to improve the mechanical, thermal, and microstructural properties of lightweight geopolymer concrete prepared using RHA and environmentally friendly foaming agents, and also to identify the optimal RHA to foam ratio that balances insulation and integrity under diverse curing conditions. For that, we use materials locally produced. Rice husk ash was used as the primary geopolymer binder. From the XRF measurement, we detect that the silica is about more than 88%, with alumina only about 4%. For alkaline activator, we mix 10 mol sodium hydroxide mixed with sodium aluminate to compensate for RHS aluminum deficiency and to form Nash gel for strength enhancement. For foaming agent, a protein-based foaming agent and lightweight pumice aggregate were utilized. Sorry. For design, the binder content was fixed at 450 kg with activated to binder ratios around 0.3 with 0.35%, and foaming content was different ratio between 0 to 2%, and mix donated as F0 to F2. For the curing and experimental program, we heat up to 60 centigrade for 24 hours to ensure heat curing well, and then we do the ambient curing for 28 days. And for the sample preparation, for composite strength, we use cubes with 100 millimeter, and for flexural strength, we use prisms with 100 by 100 by 400 millimeter, and for density, we use cubes with 100 millimeter diameter. And for the microstructural analysis, we coat the sample with gold, because as you know, the concrete is insulation and we need to have conductive layer at the top. And for the performance index, then calculated. For our results, we found out that density was decreased from 1695 to 1300 with an increase in the foam content. This reduction is attributed to the increase of air void volume. So mixes sample that we name F1 to F1.5% of foam classified as structural lightweight concrete. This is aligned with the ASTM C330. We found also that the compressive strength was reduced from 32 to around 14 megapascal, and strength above 20 megapascal maintained up to 1.5%. And also we got a trend for the reducing of flexural strength, and for moderate foam preserved integrity while reducing weight. We found out also the water absorption increased from 9.1 to 16%, and porosity also an increase due to the interconnected pores. And we got also a closed cell structure maintained below the 1.5% foam. And when we add more foam, we found thus lead to the durability concern, because the interconnected become very dense. For the thermal conductivity, it was reduced from 0.82 to 0.38. This is due to the air voids act as the thermal barriers, and we found that the optimal value is 1.5 foam with reduction around 44%. And we found also significant improvement in insulation performance. For performance index, we found the highest performance index was recording at 1.5% of foam, and this is indicating the best balance between strength, density, and insulation. For the SEM, we found at when foam percent was 0, the dense geopolymer matrix with minimum pores, and when we add foam between 1 to 1.5%, we have uniform closed cell pore structure. And when the foam was more than 2%, the interconnected macro voids that causing weakness. So the SEM was confirmed the structural property relationship with the foam adding content. For our conclusion, we found that the Husk ash-based foam geopolymer provides low carbon solution, and the protein-based foam enables controlled lightweight structure, and optimal performance was around 1.5% of foam. And this is suitable for energy efficient construction applications. Before I finish my presentation, I would like to, on behalf of the authors, to thank the University of Mustan Saria for their support, and thank you very much for your listening, and have a great day.